Let's go ahead and design that neural network that I talked about in the previous video. So it's supposed to compute logical OR. So for example, OR for false or true, that should give true, which is going to correspond to this output value. And so it'll be similar to what we did for the MNIST neural network. We're going to create our own custom class that extends the neural network module class. Always needs to have this init function in it. And then what do I want to put into forward? Well, let's make layers here. So let's say self.layers. So this is going to be part of the network that we make. And we'll say that is going to be a neural network sequential. And I guess probably I don't even need that, but that's what I usually use. So let's go with it. And this is going to be a neural network.linear. And I want to go from 2 input values, so like 0, 0, those are my 2, or 0, 1, those are my 2, to 1 output, like this is an output. So from 2 neurons to 1 neuron, and there aren't going to be any hidden layers in this neural network. And for this forward, what we'll do is we'll say, let's return self.layers x. Okay, that looks good. And then let's try to instantiate one of these. So I'll say model equals logic OR and see if that works without errors. Yep, that looks good. And now let's try plugging in X, this capital X, to the model. So I'll say model X and see what happens. So what problem does it give me? It says got argument input must be tensor, not list. So you see that this X is a list, but we want it to be a tensor. So we can say torch.tensor. Hey, this is just like saying pd.dataframe. And we'll probably want the same thing for Y. So let's go ahead and do that now. Okay, these have been redefined and models should still be okay. Let's just try plugging in X to it, which is secretly running through forward, but it's also doing some other things. So that's why we're supposed to call it this way rather than using forward. Okay, well, that previous error got resolved and now we have a different one. So it says expected scalar type float, but found long. And so that is like, for example, one silly way I could fix that is I could put a 0 dot here, which is like saying that's the float 0, not the integer 0. Okay, so that worked, but this isn't a very robust way to do it. I think it would be better to say dot 2 and then torch.float. Okay, so this is like saying we want to convert whatever that tensor is to float values, or what's inside of the tensor, I should say. We want to convert to float values. Okay, that's not the same thing as putting float on the outside, because that would be trying to convert the entire tensor to floats. Okay, and let's do the same thing here. And let's see if it still works. Yep, it gives me the exact same outputs. And we want to think of these outputs as something like probabilities. Really, we only want the answers to be 0 and 1, but on the other hand, we want something that's differentiable, so we need to allow values in between, also to reflect some uncertainty. So here inside my neural network sequential, I'm going to add an activation function, and let's use the sigmoid activation function. And let's see, what have I done wrong? Oh, I should have a comma here. And let's try recreating the model. And now when I run this, I'm hoping it shows values between 0 and 1. Okay, that'll mean the sigmoid, or that'll be evidence that the sigmoid is working correctly. Yep, great. And because this is just like totally randomly defined, so for example, if I look at model, let's say for p in model.parameters, And let's just print P. And so if you remember from the previous video, the handwritten one, we had these 2 weights and 1 bias. And so that's exactly what this is showing. These are the 2 weights. They're just like randomly created between -1 and 1. And then this is the 1 bias. And so in the next video, we'll see how we can start to evaluate the performance of this neural network. And later we'll see how we can train it using gradient descent and a loss function to try to perform better.